picture? I think this person has got an electric shock. Oh, somebody is calling from this side. Hey man, don't touch with your wet hands. Yes, but why? Hello budding charms, I hope everyone is doing well. So let's get started. Are you all ready for the session? Yes, I guess. So let's get started. And here we are going to have a wonderful lesson. And this is on the topic called chemical effects of electric current. So please pay attention throughout the class and try to take down the important points. Not only that, if you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. I'm here to help you out. And this is Aishwarya Sandhu Ramachandran. And I will be your science educator today. So let's dive into our contents. So look at this. Oh, these are the various topics that we will be learning today. Chemical effects of electric current, conductors and insulators, electric circuit, conducting liquids, electrolytic cell, and finally electroplating. It's very important because this particular session has a lot of amazing things to be learned, and I need all my students to be clear with all the concepts that we learn today. So please pay attention throughout the class and try to take down the important points. So let's dive into our main session. And what is this? It's all about electric current. Look at this. Oh, what it is exactly? Electric current. And why is it so important? To run various appliances such as TV, refrigerator, AC, etc., we need electric current. So electric current is one of the important things in our life, right? Yes. But if you take the definition of it, what it will be? It's nothing but the flow of charges. So flow of charges can be called it as electric current, right? Yes. But what about its SI unit? SI unit is ampere. Oh, so this must start with a lowercase letter. It should not start with an uppercase letter or a capital letter. It should start with a lowercase letter because this SI unit has been named right after a scientist. Therefore, we need to make sure that we use a lowercase letter when you write the whole unit. But if you try to represent it, you can make use of capital letter A. Okay, so this is the way that you need to write the SI unit. But if you talk about the various effects of it, what are they? The electric current can have mainly three effects. What are they? Heating effect, magnetic effect, and finally chemical effect. So we are going to concentrate more on chemical effect today. Okay, so let's dive into the session and look at it. It's all about heating effect of electric current. Oh, so this has various applications too. So what is meant by heating effect of electric current? When electric current passes through a conductor. So what is meant by conductor? A material that can make electric current to pass through. Okay, let's take the example of a metal. So metals are conducting. So when electric current passes through a conductor, it gets heated. Oh, this is very simple, right? Yes. So when electric current passes through a conductor, then it gets hot. Oh, so this is known as heating effect of electric current. And this has various applications too. Let's take some examples here. Iron box. How? When electric current passes through it, what happens? Yes, the heating element gets heated and therefore this heat can be utilized to iron your clothes. The application has been done, right? Yes. Similarly, when you talk about the water heater, again, a heating element is there, so this gets heated up. Clear? So this can be utilized to just heat the water. Clear? So this is the same way we have applied the heating effect of electric current in various appliances. But what about the heat produced? The amount of heat produced depends on the material, length and thickness of the conductor. This is a very, very important point. And that is what the reason we just use this particular effect on iron box and water heater. I hope you are clear. Any doubts? If you have any kind of doubts, please do let me know. And now let's get into the next one. It's all about magnetic effect of electric current. This is a second effect of electric current. What is it? When electric current passes through a conductor, again, it can create a magnetic field around it. Oh, how can we identify that? I've considered a simple circuit here. And I made this this electric current to pass through. Then what happened? When I placed a magnetic needle here, the deflection. That means a magnetic field has been produced around the conductor, and that is what the reason there is a deflection in the needle. Got it? So this is the way that you need to identify the magnetic effect of electric current. So this can be seen with the help of a magnetic needle, which shows a deflection. Clear? And if current direction is reversed, what about the direction of deflection? This also gets reversed. And I hope you are clear. And now we are going to learn the various applications of it. MCB, miniature circuit breaker. This is nothing but a safety device that can be utilized to save our different appliances if there is an excess current flow. Got it? Similarly, electric bell also works with the same principle of magnetic effect of electric current. Clear? So these are the main two effects of electric current. So now we are going to learn the third one, very, very important one. So now we are going to learn the third effect of electric current. What is it? It's nothing but the chemical effect of electric current. So for this, we need to consider a conducting solution. Look at it. In the previous effects, we have considered electric current passes through a conductor. So here we are considering a conducting solution. Got it? And when electric current passes through a conducting solution, chemical reactions take place. Look at it. It's very, very important. Chemical reactions take place. And this is known as chemical effects of electric current. So let's take an example here. So let this be the conducting solution. When current passes through this conducting solution, what happens? It is actually undergoing a chemical reaction. So due to this chemical reaction, there are various changes can be seen. What are the different changes that can be seen? Look at it. Formation of gas bubbles at electrodes. This is a very, very important one. Formation of gas bubbles at electrodes. Then change in color of the solution. Oh, change in color also can be observed. And deposition of metals at electrodes. So deposition of metals also can occur. So what are electrodes? You can see that two metallic pieces here, right? So this one and this one. So these two are called electrodes. So these electrodes are basically immersed in the conducting solution. Got it? Clear? So this is nothing but about the chemical effects of electric current. And I hope you're clear. And now we are going to learn the next one. It's all about testing potato experiment. So this is a very, very important experiment that has to be learned. So for that, what are the necessary things? Connect ends of a battery by copper wires with potato by inserting in it. So I'm taking half of the potato and trying to just keep two copper wires inserted. Okay, and look at it, here is a battery. So the ends of the copper wires are connected to a battery. The electrons from the negative potential of the battery undergo electrolysis. Please keep these terms in your mind. I will explain it one by one. Okay. So electrons from the negative potential of the battery undergo electrolysis in the presence of potato starch and release negative ions. What about the process? The electrons from the negative terminal undergo an electrolysis process. Where? It's here. So the electrons from the negative terminal undergo an electrolysis at this part, and therefore it releases negative ions. But I told you that electrolysis is happening here, but there must be a conducting solution. What is a conducting solution? It's potato starch. So potato starch acts like a conducting solution here, and therefore electrolysis occurs, and therefore what happens? Negative ions are released. But the negative ions released due to this electrolysis process are going to react with the copper wire inserted. Oh, so the copper wire inserted here has been connected to the positive terminal of the battery. Correct? And due to the reaction between the negative ions and the copper wire inserted here, it is going to create a bluish green spot because of the formation of a copper compound. Clear? So you have to be very, very clear with this idea. So there is a chemical reaction happens, and due to the chemical reaction occurs, you can see there is a bluish green spot. Got it? So I will just explain to you again. So the electrons from the negative terminal undergo a process called electrolysis, and due to this process, negative ions are released, and these negative ions are going to react with the copper wire inserted here, and this has been connected to the positive terminal. So that is what the reason you can see a bluish green spot, and that is basically due to a chemical reaction happens between the negative ions and the copper wire inserted here. Got it? So this is what the basic concept related to it. And now we are going to learn the basic differences between conductors and insulators. Very, very simple one. So we know that conductors can allow electric current to pass through. And what about insulators? We know that materials that does not allow electric current to pass through can be called it as insulators. Now we are going to talk about conduction. Oh, look at the picture. I think this person has got an electric shock. Oh, somebody is calling from this side. Hey man, don't touch with your wet hands. Yes, but why? Water which is present on your hands can act as a conducting solution. Oh, that could be the reason you get the electric shock. So water can act like a conducting solution, and this can really be dangerous. Oh, that's an important thing, right? Yes. And we need to avoid these kind of situations and don't touch any electrical appliances or any switches with your wet hands. You have to be very, very cautious about it. And now we are going to talk about conducting liquids. I told you, right? Conducting liquids can be of different types. All liquids cannot conduct electricity. Some liquids are good conductors, whereas some liquids are bad conductors of electricity. So let's take some examples here. So vinegar. So vinegar is considered as a weak conductor. It is a conductor, but it is a weak conductor. And what about vegetable oil? It can be a poor conductor. Clear? And what about mercury? So mercury is a good conductor again. And what about honey? Honey also can be considered as a poor conductor. And what about lemon juice? Lemon juice can be a good conductor again. And distilled water is considered as a poor conductor. Why? Because distilled water has no salts or minerals in it. And that is what the reason it is acting like a poor conductor here. So I hope you are clear with the points. And now we are going to learn conducting liquids again. And we have to consider acids and bases too. So acids and bases are considered as good conductors because these chemical substances can dissociate to form various ions when dissolved in a solution. So these can be considered as good conductors for sure. But what about salts? Again, a good conductor. Salt dissolved in water releases positive or negatively charged ions. So this can be conducting again. And what about distilled water? I told you, right? It is a poor conductor. Why? Because there are no salts or minerals present in it. Clear? If you consider the normal water, the pure water, it can contain a lot of salts and minerals. So this can be conducting. But if you take distilled water, there are no salts or minerals present. And that is what the reason it is considered as a poor conductor. And now we are going to talk about electric circuit. Oh, that is a very, very important one, right? A closed path where electrical components are connected can be called it as electrical circuit. So we have learned different types of electrical components, right? For example, bulb, then switch, then the cell. These are considered as various electrical components. So these components can be connected with wires to create a circuit like this. Are you getting my point? So you can see that here we have a bulb. We have a switch, then we have a cell. So these are connected with the help of wires to form a circuit like this. Clear? And these are basically classified into two: open circuit and closed circuit. What are the basic differences between them? So for that, we need to analyze the pictures of it. Can you see any gaps here? No, right? Everything is so much closed. right? So no gap or break present, and therefore current flows in the circuit. And that is what the reason we call this as a complete circuit. You can see there is no gap in between. We have a cell, we have a switch, and we have other components too. So what happens when these are connected? There is no gap present, so electric current can simply flow through it. And that is what the reason we call it as a closed circuit or complete circuit. And please make sure that current can flow only through a closed circuit. Clear? And when you come to the part of open circuit, yes, it is open, right? You can see that there is a gap, right? It is completely open. So here, a gap or break present, and therefore current doesn't flow in the circuit, and that is what the reason we call it as an incomplete circuit. This is a very, very important point. Clear? So current flow happens only in a closed circuit. In an open circuit, current flow will not happen. Clear? And now we are going to learn tester. You might have learned about this tester, or at least seen the tester in your life, right? What is it exactly? A piece of electrical equipment to determine the presence of electric current. You might have seen electricians use this particular instrument or a device to check or to determine the presence of electric current. They have to simply touch and find out the current is flowing or not, right? But how? A conductor with an LED bulb. That means the tester has a small LED bulb to indicate the presence of electric current in the circuit. But why did we use an LED here? We could have gone for something else, right? Oh, why? Because LED glows even when a weak current passes through it. So even if there is a minute amount of electric current, it can really blink. Clear? That is what the reason we have selectively chosen this particular LED light inside our tester. So LED has a long lead and a short lead. Long lead is connected to the positive terminal of the battery, and the short lead is connected to the negative terminal of the battery. So this is a picture of a LED bulb. So you can see that there is a long lead and there is a short lead too. So the long lead is going to connect with the positive terminal of the battery, whereas a short lead is going to connect with the negative terminal of the battery. So this is a way that you need to connect. And now we are going to learn electrolytic cell. Oh, so what is meant by that? Look at this. Let me change the color once. A conductor immersed in a chemical solution with its ends connected to the terminals of a battery completes a circuit is called electrode. Two metallic pieces connected to a battery and immersed in a conducting solution. Clear? So the solution in which electrodes are immersed can be called it as electrolyte. See, this is the electrolyte. Okay, let me change the color. So this is the electrolyte or conducting solution. So this solution has a power to undergo a chemical reaction when electric current passes through it. So here we have a conducting solution in which two electrodes are immersed. Clear? And the electrolytic solution dissociates when electric current passes through it. I told you, right? The conducting solution has a capacity to undergo a chemical reaction when electric current passes through it. Through this, it can dissociate to form ions. That is an important thing, right? So it can dissociate. It can dissociate when electric current passes through it. So the electrodes, electrolyte and battery together form electrochemical or electrolytic cell. So if you want to say electrolytic cell, you have to consider the whole setup. Okay, you have to consider the whole setup. So I will tell you once again, the battery, the electrodes and the electrolytic solution. So these three things all together can be called it as electrolytic cell. Clear? So two electrodes have been connected to a battery and these electrodes are immersed in a conducting solution or electrolytic solution, and the whole setup can be called it as electrolytic cell. Clear? And now we are going to talk about electrolysis of water. So what happens if electrolysis occurs with water? Oh, that is an important question, right? So for that, you need to consider electrodes again. And these have to be immersed in water and electric current has to be passed through it. When electric current passes through water, what happens? Oxygen and hydrogen bubbles form. Look at this picture, you can see that, right? Yes. So oxygen and hydrogen bubbles form. And when you talk about the bubbles, oxygen bubbles formed on the electrode connected to the positive terminal, whereas hydrogen bubbles are formed near to the electrode which is connected to the negative terminal of the battery. So this is a way that you need to understand the point. And now we are going to talk about electroplating. What is electroplating? So depositing a layer of desired metal on another material by means of electric current can be called it as electroplating. Clear? So this chemical effect of electric current can be utilized to do electroplating too. So what does mean by that? We are coating a metal on another material. Clear? Using this particular effect. So let's see how it is going to happen. So what are the various applications? Coating silver and gold for jewelry. So we all love jewelries, right? Yes. So if you want to coat silver or gold, you can make use of this particular process. Similarly, coating zinc on iron to prevent corrosion and rust. So iron can definitely undergo a process called corrosion. Therefore, it starts to rust. So to avoid that, we can have a coating on it. But what coating? A coating of zinc can be given on iron metal. Coating tin onto iron cans due to its less reactivity and to avoid spoilage. So you might have seen tin cans, right? So these are basically made out of iron but coated with tin. Got it? So for this also we can make use of the process electroplating. And chromium coating on car parts for the shiny appearance and to resist scratches. So we know that chromium is extremely expensive, right? Yes. So a cheaper metal can be used to make these kind of parts and can be coated with chromium so that it can resist the scratches too. And now we are going to talk about electroplating experiment. So this experiment is very, very important. So electroplating experiment also has to be learned. So ingredients needed. So what are the different ingredients needed? Dissolve 2 teaspoons of copper sulfate in 250 ml of water. So we need water and we need 2 teaspoons of copper sulfate powder. So when you dissolve it, you get a solution of it. Then you need to add a few drops of dilute sulfuric acid for better conductivity. Clear? So these are the main ingredients that we need. Then we need 2 copper plates of clean nature. So these copper plates are going to act as electrodes. Clear? And what are the steps? Connect the copper plates to the terminal of a battery. So look at it. We have 2 copper plates. So here is the first one and here is the second one. We have 2 copper plates and these are connected to a battery. So this is nothing but our battery. Yes. Okay, so we have the conducting solution here, which is nothing but a solution of copper sulfate has been added with 2 drops of dilute sulfuric acid. Clear? That is what the solution that we have considered here. So now we are going to talk about the copper plates immersed in the copper sulfate solution. And here what we are going to do, we are going to observe the things. Look at it. When electric current passes through the solution, copper sulfate dissociates into copper and sulfate ions. Very, very important. So when electric current passes through the whole setup, the solution can dissociate. So how it is going to dissociate? It is going to dissociate into copper and sulfate ions. That's the first point. I told you that this is a conducting solution. So when electric current passes through it, it dissociates into copper and sulfate ions. So there are 2 types of ions that have been formed here, copper ions and sulfate ions. Clear? And what is happening to the copper ions? The free copper ions drawn to the electrode connected to the negative terminal of the battery. So this is nothing but the electrode that has been connected to the negative terminal of the battery. So I can name it as number 1. As I told you that the copper ions from the solution is going to get accumulated in the electrode connected to the negative terminal. To balance the number of copper ions, the second electrode is going to release copper ions to the solution. Clear? This is how the balance has been done. So this process is going to have a continuation, and therefore this can make a desired metal to be coated on another material by the means of electricity, and this can be called it as electroplating. Clear? So this is a way that you need to understand, and look at it. It's all about the summary. So we have discussed various concepts today. Started with chemical effects of electric currents. Then we discussed conductors and insulators, electric circuit, conducting liquids, electrolytic cell, and finally electroplating. So I hope everyone is clear with whatever the concepts that we discussed today. So that's the end of the class, and I hope you really enjoyed it. So that's the end of the class. We'll see you next class with an amazing session similar to this. So have a nice day and goodbye everyone. Thank you so much.